All right, if you've ever worked with Cisco ACI, I guarantee you've run into this exact question. What on earth happens to a packet when the fabric has no idea where it's supposed to go? Well, today, we are going to pull back the curtain and demystify Layer 2 unknown unicast traffic. Trust me, understanding this is absolutely essential for troubleshooting and really getting the most out of your ACI deployment.
So, here's our game plan. We're going to start with the basic problem of unknown unicast traffic itself. Then, we'll dive into ACI's two very different ways of dealing with it. From there, we'll see it all in action with 3 real-world scenarios, and then we'll wrap it all up with the key things you absolutely need to remember.
First things first, let's set the stage. This whole conversation really hinges on a classic networking problem. A switch gets a frame, it looks at the destination MAC address, and it basically just shrugs and says, I have no idea where this is. What happens next? And that, right there, is what we call Layer 2 unknown unicast traffic. Now, in a traditional network, the answer is usually pretty simple. Just flood it. Send it out every port in the VLAN and hope for the best. But, as you're about to see, ACI is a bit more sophisticated and gives us some much more intelligent options. This is where ACI really gives you control. Inside any bridge domain, you get a choice between 2 modes. There's hardware-proxy, which is the default, and then there's the more traditional flood mode. And let me tell you, the choice you make here is going to have a huge impact on how your fabric behaves.
So this slide really gets to the heart of it. Think of it this way. In hardware-proxy mode, the leaf switch basically says, I don't know this MAC. I'm not going to guess. I'm going to ask my boss at the spine. It's a centralized lookup. On the other hand, flood mode says, I don't know. Well, let's just send it out to everyone in this bridge domain. One is all about efficiency, the other is all about discovery. Okay, let's start with the absolute simplest setup you can imagine. We've got 2 hosts, H1 and H2. They are plugged into the exact same leaf switch, they're in the same bridge domain, and using the same VLAN. Easy, right?
So here we are in hardware-proxy mode. H1 sends a frame to H2. Now the leaf looks in its local table and it has no entry for H2's MAC address. But look closely at the traffic flow here. The packet doesn't just go out the other local port. Nope. Instead, the leaf wraps it up and sends it up to the spine to make the decision. This is a really key concept. Now it's all up to the spine. The spine checks its massive, fabric-wide endpoint table. That's the COOP database. Think of COOP as the fabric's single source of truth for where every endpoint lives. Now in our case, H2 has been silent. It hasn't sent any traffic, so it's not in the database. And because the spine can't find it, it just drops the packet. It does this on purpose to stop unnecessary floods. Okay, now let's go into that same bridge domain and just flip the setting to flood mode. Same exact scenario, but look at that, a totally different result. The packet from H1 now goes straight out the local port connected to H2. This looks a lot more like the traditional switch behavior we all know. So this local flood makes sure that H2 actually gets the frame. And as soon as H2 sends a reply back to H1, bam, the fabric learns its MAC address and its location. It gets added to the table on the local leaf and in the spine's COOP database. So you can see flood mode is all about prioritizing discovery to get that initial connection working.
All right, time to level up the complexity just a little bit. Now our hosts, H1 and H3, are on 2 completely different leaf switches. They're still in the same bridge domain, but now our traffic has to actually cross the ACI fabric to get where it's going.
This slide is perfect because it shows the 2 forks in the road for proxy mode. On the left, let's say H3 has already been active, so the fabric knows about it. The spine gets the packet, does a quick lookup in its COA cheap database, finds H3, and sends the packet directly to the right leaf. Super clean, super efficient. But on the right, if H3 is a silent host and the spine doesn't know about it, we get the same result as before, packet dropped. So in hardware proxy mode, you really have to think of the spine as the all-knowing decider. The first leaf just passes the buck. This is awesome for performance with known endpoints, but it creates this kind of potential black hole for silent hosts, devices that just haven't spoken up yet to let the fabric know they exist. Now, flood mode, of course, does things completely differently. The first leaf doesn't bother the spine proxy. Instead, it takes the original packet and wraps it in this special multicast header. They call it a group IP outer, or GIPO for short. And this GIPO address is basically a multicast address just for this one bridge domain. So this multicast packet gets sent out across a pre-built loop-free path to every single leaf that's part of that bridge domain. This is a guarantee. It guarantees the frame will get to H3's leaf switch.
and that leaf then sends it out the local port, which of course lets H3 get discovered as soon as it replies. Okay, last scenario. Let's add a twist that you see all the time in the real world. What if our endpoints are in the same logical bridge domain, but they're using different access VLANs? This is one of the really powerful things about ACI. So let's put both hosts back on the same leaf. H1 is on VLAN 2014, and H2 is on VLAN 2025. Now, you might think this changes things, right? But in proxy mode, nope. The forwarding logic is exactly the same. The leaf only cares that it doesn't know the destination MAC. It forwards to the spine also doesn't know, and the packet gets dropped. The different VLANs don't even factor into the decision. But check this out. This is where flood mode and the whole concept of the bridge domain really shine. In flood mode, the leaf floods the packet to all ports that are part of that BD. And since both of our VLANs are mapped to the same bridge domain, the packet gets delivered to H2, no problem. The leaf even handles the VLAN translation from 2014 to 2025 for you. Pretty cool.
Now let's put them on separate leaves again. In proxy mode, if the spine knows H3 is on that other leaf using VLAN 2025, it does something really intelligent. It doesn't just forward the packet. It includes the policy information so that the destination leaf knows to put the correct VLAN 2025 tag on the frame before sending it out. But of course, if the spine doesn't know about H3, well, you know the drill by now. Dropped.
And for our grand finale, flood mode once again acts as the ultimate safety net. The packet gets flooded using that GIPO multicast to every leaf in the bridge domain. When it gets to the right destination leaf, that switch already knows H3 is on a local port with VLAN 2025, and it takes care of the final delivery. Discovery is, once again, guaranteed. Phew! Okay, we have covered a ton of ground here, right? We've walked through how ACI handles this traffic, from the very simple to the pretty complex. So now, let's just pull it all together and really zero in on the key takeaways.
This table really says it all, doesn't it? Look down the columns. In every single scenario we looked at where the destination was unknown, the default hardware proxy mode dropped the packet every single time. And flood mode, it delivered the packet every single time. This is the fundamental trade-off you are making when you configure your bridge domain.
So why does this matter? Well, it has huge real-world consequences. If you're ever troubleshooting why two endpoints can't talk, the very first thing you should check is the bridge domain mode. If you have silent hosts, think some storage arrays or server management ports, they might be completely unreachable in the default proxy mode. At the end of the day, it is a conscious design choice between squeezing out every bit of performance or guaranteeing that discovery will always work.
And that leaves us with a final question for you to think about. Hardware proxy is the default for a very good reason. It cuts down on wasteful traffic, and it keeps the fabric efficient at scale. But based on everything we just covered, think about your own network. What are the specific applications or use cases that would make you say, you know what? For this bridge domain, I'm going to enable flooding. Thanks for joining this explainer.